Good afternoon, everybody. It's my pleasure to introduce our project titled A Complete Lock and Unlocking Mechanism for Launch Vehicle Applications. It was an open challenge to design a locking and unlocking mechanism with rocket radio connection bolts for launch vehicle applications. This project deals with the challenge associated with the mesh radio connection and aims to obtain the following characteristics of quick net, quick release, high reliability, high loading capacity, small impact, security, and reusability. The widely used lock and unlocking mechanism equipped with rocket end-shell connecting bolts, so windows on the rocket housing are needed to operate the bolts, is quite inconvenient, leading to longer locking times. Therefore, locking and unlocking mechanism with rocket radio connection bolts is desired, but such a design is quite difficult. For reliable unlocking and separation, there should be a big gap between the outer surface of the inner cylinder and the inner surface of the outer cylinder. However, for reliable connection, the gap is not allowed. Researchers and engineers are struggling for solving the conflicting design requirements. This project proposes a new design with rocket radio connection bolts, including quick release mechanisms, then reducing bolts, outer cylinder with U-shaped holes, complete scissor mechanism, and complete inner cylinder. The diameter of the complete inner cylinder is variable as required. The locking procedure is as follows. Outer cylinder and the complete inner cylinder. There is a gap between them. Phase sleeve and the threaded sleeve, wedge blocks are employed to lock them together. Stamp reducing bolts are used to connect the cylinders together, and the diameter of the inner cylinder increases until constrained by the outer cylinder. The unlocking procedure is as follows. The wedge blocks are pulled out quickly, and then the stamp reducing bolts and the threaded sleeves are ejected by the springs. The inner cylinder returns to its original state with a smaller diameter. As a result, the outer cylinder is free to separate from the others. There are 4 main contributions and novelties. The first contribution is the design of the complete inner cylinder. The inner cylinder arranges multiple independent lobes along its circumference, and the root of each lobe is connected to the inner cylinder with a complete height. So each lobe can be translated inward or outward in the radial direction, and thus change its diameter as required. However, the various lobes on the inner cylinder may also move out of sync, resulting in an irregular cylindrical surface. We utilize a complete scissor mechanism to constrain the lobes always on the same circle. Compared with the rigid body scissor mechanism, the complete one is lightweight with less components. The complete scissor mechanism is the second contribution. The third contribution is stamp reducing bolts and the outer cylinder with U-shaped hole. The design of the stamp reducing bolts can greatly reduce the time for tightening the bolts during assembly, and the manual assembly time is reduced by about 67% in particular. The design of U-shaped hole ensures that the inner and outer cylinders are able to separate reliably, even though the connecting bolts are not fully ejected. The fourth contribution is a quick release mechanism, which is used to keep the wedge block plugged in reliably by means of the circularity configuration, and to pull out the wedge block quickly by means of a metamorphic mechanism that can transmit from a 5-bar linkage mechanism to 4-bar linkage mechanism. The kinematic model has been derived, which is also verified in the FEA simulations. A prototype of the design was manufactured and experimentally tested. The experimental results verify the proposed design with the desired characteristics. We have applied for the patent protection for the design. Many thanks for your attention.